Yeah, now I'm going to talk about actual programming of a PLC in structured text only. These legacy programming languages like ladder logic and FPD, they are poorly suited for advanced control tasks. Those are usually, they are suited for combinatory logic, which in factory automation you can use it, but you can use structured text program or high-level language program just as elegantly as ladder and FPD. Again, it's a walkthrough through this is the chapter 4 here, structured text programming. Yes, general. There's something down here. TI Portal does the TI Portal editor does not support, for instance, column editing and stuff like that. So it's not that powerful. So here it says Notepad++. There are other editors that are just as good, but Notepad++ is free. So where you can do column editing, for instance, I'm going to show a quick one here. Here's Notepad++ with some A's. So if I select a column here, like that, I just, for Notepad++, I have the Alt button pushed and the right mouse button. Left mouse button, I mean. So I can edit this. Here I could write B if I want to. And things like that. And also column copy. I want to copy this here. And I want to make this. See? So that's column editing. And also Notepad++ can colorize, for instance, structured text programs. Because structured text is Pascal. Of course, you could tailor Notepad++ to match structured text exactly, but that's not that important. Well, okay. Yeah, it's general. How to store data data program you make yourself, don't lose those. Store it somewhere you know where you have it and make a backup of it. Preferably have an automatic backup system or something. Here's just a suggestion of names that you could use. Oops, yeah. Oh, here should be TIP project. There's a typo error. It's not that important. They are S7 anyways. How to make a backup? Make backups. You have had a disk crash, or you will get one. So backups, they're important. And here are just some suggestion how to make backups with a date and a timestamp optionally. Here, if you make more backups every day, at least a backup every day, and if you do extensive work, make backups more often. Yeah. So those are just suggestions. And then we have naming conventions for the program element that we have talked about. The semantic does not have a program, so this will be an FC. The green color here is an FC. PRG main, this is your main program. User data blocks is DB. Instance data block IDB. Instance data. Tasks TSK. User data types TPE. You could call it something else, UDT or something like that. But it's a type, a data type. Tag tables, if they're global tag table, global, all IO is global, can be accessed from everywhere in the program. A little dangerous practice. They should be private to the program using IO, but whatever. That's what TI Portal offers. Global tag table IO. And a global constant table standards where you have constant, because you can have global constants too. Yes. Yeah. In the base folder, you should program it like this. You should you could prefix it with an alpha, because it has to do with the sorting. Because in the catalogs and TI portal does automatic sorting. And then we have got a startup function. What's really important for a PLC is to remember startup. When the PLC starts, you have to pick up the state of your process, and that's where you have to start to control. Don't start things when your PLC restarts, a valve open here, or motor starts there, valve closes there. It doesn't look good. Yeah. Okay. So here's an example. This is actually from a project that we are going to use, how to organize this. We have library functions. They are linked to a library somewhere else. These are know-how protected. And then we have the program under here. They're all under program blocks. We don't have anything else. And here we have got the task background, cyclic task, a restart task. These are some special instance of function measuring runtime, which can be important, and so on. So this shows how to organize it. A reset task, yeah, it should be called like this. These programs, they are in the template, and this is pre-made. So this just sets an indicator that the PLC is restarted. All the programs can use and do whatever they have to do when on a PLC restart. So this is the background. The background task is a cyclic task. So when that task is finished, it restarts. And here is a simulation program that you should make, because when you do program, you have to test it. You have to simulate your process, because normally you can't sit in the process and try and do trial and error, because that can be dangerous. And here's the main entry point. So whatever you program, you enter in here in this program main. The cyclic task, it's an example. It could be anything, but this one is 5 milliseconds. There's nothing in here. But if you have a cyclic or something that would require 5 millisecond processing, you would put it in here. Yeah, it has a little how to further organize this stuff. So these are suggestions. Yeah, and template handling, there is on the right hand side here, we get into that later on. There is a library where you can put your own, the things that you make yourself, you put in a library, and then there are some pre-made functions that you can use. Yeah, there's a general, of course, a programming element requiring static memory. You have to remember for each execution of your program cyclically, have to remember data, has to be a function block. And here it says, okay, this has to do with object orientation. What we are controlling in a process are valves, motors, whatnot. And I make a function block to control a valve, maybe more if I have more valve types. And that's what it does. It controls that valve, nothing else. You don't put in, let's say it should be capable of handling 2 valves in parallel. You don't put that in the same function block. Then you have a function block controlling the valves separately, and then you make a new function block that coordinate these 2 valves, how they should operate in parallel or in series or whatever. Yeah, and there's some exception. Functions, they are functions. For instance, adding 2 numbers, you can do that more conveniently if you don't use a function for that. But functions, they don't require that. And these source files, they look like this, but they are stored in TI Portal database, and they don't look like that. But if you export them, okay, they are going to look like this. In the code, you should put something like this in here. This is something I make on the top, at least. Who has made this stuff? You work in a company, write your signature in that, so people know who made this program. Guidelines, there are some Hungarian notation stuff that you can use, that we are going to use. And there are some naming convention according to an international norm 63131, how they name. We're going to look at that briefly later on. All programming language, this is high-level language, you use English language. No other languages in here. Not variable names in your native language, no. It's English language only. And here is how to set up your editor. And you can find this in TI Portal, your options and preferences, I think it is. And set it like this. These are colors set up to match roughly Visual Studio, where you can. Tabulate to use spaces, not tabs. Yes. Input and outputs uppercase only, and then it's this norm that we are going to look at later. There's inputs and outputs and in outputs, but you get inside what is only visible to your program. The user can't see. Now the user can see this because the information hiding in the TI Portal is pretty poor. Static or internal data and function block, you can access those from outside your function, block, and that's not good. It shouldn't be like that, but that's the way it is. Here is the way we do naming. We have a type first, a memory area first, static memory, and then we have a type, integer, and then we have the variable name. And this is camel case, no underscores, capital letters, even if there's an OF in here, OF, there's a capital O in it, and so on. Abbreviations or acronyms, that's capital letters. You write them with a capital first letter, and then it's lowercase letters following. How to name temporal variables. Complex variables is a little special. A function block, for instance, is a complex variable. So they just start with arrays. If you have a vector, of course, you would just say, if I have an array of integers, it would be static integer and array name, something like that. But if you have user types, they don't have a type, it's a user type. Constants, lowercase c, to indicate this is a constant. It has to do with the readability in the program. You can look at a variable and say this is a constant. I can't write to a constant, it's constant. So there's no point in assigning anything to a constant in a program. So it has to do with readability. So of course pi as an example, CR pi, constant real pi, or long real pi. Okay. Global you can use, but if you have to name them like this, you shouldn't use them. Yeah, and then it has to do with robust programming. Some important thing here is if you are doing computation using real number or long real numbers, you can end up with a legal number, not a number, or infinite numbers, something like that. It's important to check that when you do your program, first you try to avoid producing a legal number, but you could use a check. And in this template project that we are going to look at later, there are two functions for real number exception, long real number exception. So you can pass a result of a calculation into this function, and it's going to tell you, is it faulty or not? Is the result a valid number at least? It might not be the right number, but at least it's a valid number, floating point number. And this is the here with the poor information hiding in TI Portal and Semantic PLC. So it's absolutely forbidden to access the static section, the private data for a function block, from outside the function block. This is something that you can't do. It's illegal to do in the program. You can do it, but if you do, it's not good. Okay, now here, global variables or variables without name, don't use them. So if you have a Boolean global in memory, now in TI Portal, you have to name them. So this is a little legacy, you have to name them. Then there's a structure of a program. Temporaries, they are 0 or arbitrary values. Initialize those to whatever you need. They should be 0, write 0, even if in the new CPUs they would be 0, but just write 0 so people reading your program say, okay, he wants this one to start at 0, nice, or false or true or whatever. So what you do is validate inputs. You have to validate the inputs. If a number should be between 0 and 100, make sure it is between 0 and 100. Do whatever your program should do. Write to the results, to the outputs. These are function blocks or functions. And then we don't have to look there. If you have an HMI system that needs variables, it should have its own variable. Do that at the end, because then you have produced the results you need, so you don't transmit some intermediate results to your HMI system or something, because your program is done. And now you can say, okay, what I have produced here, it's the same as the outputs. What I have produced, write it to the outputs. I finished with my processing. What I am outputting is correct, hopefully. Now, element structuring. Don't write more than one statement on one line, and the statement is a name, assignment, some mathematics or whatever, and a semicolon end. That's one statement. There should be a semicolon too, and should be semicolons too. Well, whatever. That's what's for the purpose. One instruction on one line. Use overdue parentheses. This one would end in. This one would end up as. It wouldn't add anything, because this would evaluate to 0. 1 divided integer number. 1 divided by an integer 2 would result in 0. So if that's what you want, it would be 0. But if this is what you want, that would produce half of whatever this would be. Yeah, declarations. Here we have got constants. Group them. What are you using these constants for? Here are just examples. Here are some. This has to do with time shifting in a sample system. We usually use k minus 1, k minus 2, and then we don't use the CI. Whatever. But this is just their example. Comments. What to use a good variable naming practice to achieve self-documentary programs. Name your variables with nice names, so we don't have to comment to explain what does this variable mean. They can be long, and long variables does not require any more processing time than short one. If necessary, usually if you have complex programs, you should document them. Before you start writing code, document them. These are these are kind of meta text codes that documentation robot will use to extract information. Yeah, that's what should be common. Jumps you can do it in structured text, and it's absolutely illegal. You can't use goto. It's absolutely illegal, but it is possible. It is just like writing to the static section of a function block. Don't do it. Yeah. Case and if, rewrite if you have if statement, but just go if, rewrite. Here's the case statement. Should look like this. And in structured text, for now, the case that you are testing is numeric. So this is a number, and then you would use a constant, say, what does this state mean? If it is the number 1, okay, you write 1, but if it means something else, the state you are in, or the case you are in, so say, write what the case is doing or whatever. Block indentation, here are tabulator of 4 spaces. Here's an example for nested if sentences. Should do it like that. Here's for 4. If you call a subfunction a function, notice here that the assignment, they are aligned vertically, because that's important, because here's where you change things. So if if you let TI Portal Editor align this automatically, there might be an assignment that you kind of oversee. You just can't see it because it's way left. So the assignments, they are aligned, all assignments in your program, vertically aligned. Notepad++ can do this for you. You can just copy it into Notepad++ and just align it. The TI Portal Editor can't do it. Inherited function block. If you make a function block, it's a data type, so you can just declare it in another function. So here we have a function block called analog alarm, and it's a static type. You can only put them in static. You can put them in input and output. I think don't do. They are in the static, they are private section. So what we have here is some alarm. This is a function block that checks a limit, that a value is above or below a limit. And I have more in this one here. So do it. And if you call them, this is an example for the filter down here. Alignment, vertical alignment for assignment. The y here could have written below here, y equals TRY. And then you get an error that pointing out of the call here. So these are just suggestions. So I could also write all these assignments as filter.x : equals TRY per semicolon to end it. Timing. Timing is awfully important in the PLC programming. Here's an example of timing. So what you do is that this time tick function, that is a millisecond counter that you can read out of your operating system in TI Portal. And it counts from 0 to 2 million something milliseconds. It's roughly 24 days on something. So if you have a static variable that you remember here, because in a PLC your program is executing cyclically, and if you stay in a function block in a perpetual loop or something, your PLC is going to stop. You can't do anything because it's only your program working, your FB or instance is working. Nothing else is being processed in the CPU. You could put something on interrupt on something, but that would interrupt this, that would work. So you do timing like this, is that your program start up here, and you have something called TT now, which is in the top, assign temporaries, TT now, that's the time tick now, and then you calculate now and something you have saved. And then you say, okay, as this is counting 0 and up, it can wrap. This difference can be negative. And what you have to do then is to add the maximum positive value to this to make it correct time. And then you just check the time, do something, and now you can, for instance, initialize your timing system by saying ST time is now TT now. Static time now, static, it remembers it to the next time the program is called, is now. So next time it comes back, read now, but now it's roughly equal. It's the difference between, if your program take 1 millisecond, there's going to be 1 millisecond between there. So then this time is 0. So it's not often that this one is, but you go down here, it's not above the set point, doesn't execute this. Maybe here the program is over, don't do anything more. Next loop, TT now increasing until the difference here is greater than your set point. Do something, reinitialize, and we start over. And this is going to run like this all the time. This wrapping, do that, for instance, with a number between 0 and 100 as an example. Let's say this time tick comes from 0 to 100. And now I saved my time for, when I was last in, I saved 99. And then I go back and I'm going to wait for 3 seconds. So I get back here. And this one, I've saved 99. And then it gets 100, but that's not 3, it's 1, the difference. And then next time I get back, it wraps to 0. And I'm 99. And now let's say 0 minus 99, that's minus 99, and the maximum number on my timeline is 100. So if I get back, if I get a negative number, so now I get to 0 and I have 99, I get minus 1, and then I add 100 to minus 99 plus 100 is 1. But it's still not greater than 3. Was that what is specified? Okay, then I get to next time. I get 1 out of my my now here, and 1 minus 99, that is minus 98, and plus 100 is 2. Still not greater than 3. Next time I get that was 1, I get 2. I'd say 99. 2 minus 99 is 97. And I add 100, that's 3 minus 97 plus 3, that's 100, no, plus 100, that's 3. It's greater than 3. The difference, do something, save, and now I'm going to save 3. And then I'm in good shape, because next time it's going to be 3, 4, 5, 6, which the difference is 3, and I will do save 6, and I will count down. And of course this time tick goes to 2 million something. It's not going to happen. It's going to happen every 24 days. But if you don't do this, your timing system is not going to work. And then also in this project, you have this made a function. It does not exist as a firmware function. But now let's see. Now more than one timer first. There were long timers down there. If you need more than one timer, just make arrays out of these TT times and stored times, and then use some constant. Say, okay, this is a pulse timer. Next one is a wait timer. There's an off timer, and whatever. If you need more than one timer, but you doing this a lot of times, you don't need more than one timer because you can reuse it. And then there is also this long-time function. This long-time function is not a part of the operating system in SIMATIC, but then you don't get this wrapping here, because the long time works for 500 years or something. Then your PLC is going to be gone, or at least not working anymore. But basically it's the same. So you don't have to check this wrapping. Then we have edge tested in PLCs. They are working a lot of binary signals, and something should happen. If a signal goes from false to true or true to false, you should do something. As long as the signal stays true, you don't need to do something. In combinatory logic, you would do it all the time, but you don't have to, because you can process on a change as long as it stays true. Most of the time, you don't need to do anything. So here's an edge test, and it works like this. Again, the code iterates itself. It just repeats itself. So it runs in a loop. So let's say we go in here and xt is false, and the static Boolean xt is also false. So when these are false, false and not false is true, but false and true, that's false, because that's the and sentence. For and, they both have to be true for the results to be true. And then I save my result. So okay, let's say I go through and then xt turns true. True and not false, true and true, true. This one is true, but then I save my input, so this sbxt, static Boolean xt, becomes true. So next time I run through here, xt is true, but sbxt is true and not sbxt is false, so then it's true and false is false. So that's just in that moment that xt turns true, it executes tb is true, and then I do whatever I want when this changes. So that's when this turns true, I do it. I could do an exclusive OR, which means that these are not equal. Then I have a positive edge and a negative edge in the same instruction, because I use this. This is a change of xt. Either goes through or low. Then this one is true, and I could do this, like this. Okay. And this instruction even work on what we call binary types, byte word and double words. So if I have a byte, I can make an edge test on 8 bits of booleans in that byte in just one chunk, using the same way. Yeah, and then we have looping instructions for while and repeat. But again, we would prefer while and repeat loops. They can lead to infinite loops, or 4 can too. But now in the newer versions, the loop counter that you use in a for loop, you can't manipulate it in the loop, so it's going to time out at some time. Of course, it can take some time, but still. So try to use the for loop because it automatically ends. But if you have to use other looping structures, do those. Then we have something called finite state machines here. And a finite state machine is what it says, it has states. Doing programming, you would like to use finite state machines because in a process, you process in finite states. It's in states, it can't be a lot of states at the same time. For here is an example that's also left as an exercise. Is an element controlling something we call a bistable element in your process. That's a finite state. Bistable, it can be in this we use the names low and high. Low means it's not active, and high means it's active. So it can either be active or passive, or something in between often. It can be in transit from passive to active and inactive, but it can't be active and passive at the same time. So it has finite states. And what's kind of smart is to make a finite state machine that commands this object or element between its states through this transit states. And yeah, so that's a finite state machine. This is quick. User data types should start with type, and those are interactive. It's a table that you enter in TI Portal. Same with data blocks. So these are the prefixes that was earlier too in this. Track of the program is like this. This TI Portal offer this tracking, but here is a suggestion for alpha, beta, final release candidates and released for the first number. And then we have minor, major changes, and so on. Minor changes, change the comments, for instance. You don't need to retest because it doesn't do anything, but there is a change in your function. But if I have this version of the block, and now I have this one is a change, okay, it's a comment. No consequences. Could be variable name change too in the temporary section, because as long as you don't change the type, it doesn't matter. But if you do something in the code section or static data and something like that, maybe you need a full test, and people reading seeing that this has changed. Okay, maybe I need to do or get a test document of this function, find out what has changed here. And if you change the interface, inputs and outputs, okay, then you should retest this, whatever. Or if this is out of a library or someone is using this function, they just have to read the test report and say, okay, I'm going to be fine with this. So that's version. Yeah. So that was programming. Again, quick. So this with edge testing and timing is important here. And also this naming syntax and stuff that we have been used. And that is down here after, and this is going to be later, this functionality. Yeah, Hungarian name, and here's a table. So what we do is we say, okay, what kind of memory area type is this? Also for input image, you could use IB, input Boolean, for instance, like down here. But those variables maybe have a tag system that you can't name them like this. But if you decide yourself, you can write II, and then you look at the variable in the program. Okay, this is an input, an integer input, or IB input a bool or whatever. So that's the memory area that you are working on, and constants too. These are in these I and Q, they are in the PLC tag tables and not in your program. Okay, and then is the data type down here, and the reason why is now in TI Portal you get tooltip text. If you hover your mouse over your variable, it tells you what kind of type this is. But you can't do that. It's much easier to have a system say, okay, this is a byte. I know it's a byte. It's named as a byte. But when you program, you better make it a byte too, so you don't fool people. So here here are some examples: static Boolean, input byte, output integer, global, constant, real, and so on. And here are these complex structure or user data type. Temporary user data type, and it's a Boolean variable in here. And here is the same type with a byte in it. And here are arrays, an array of these types, whatever, structures. So then, of course, it's a user data type. You could call it TUDT, a TTPE, T-type, or something like that. But whatever. If it's nothing, it could be a function block, not in the temporary area. And then it's deriving too. Here is, if you use this system, let's say I have an input Rx, reset external, we get to this later. Then I could use SPRX. Okay, there's something has to do with this input, and TBRX, Boolean, has something to do with this Boolean input. And then the programming reading it says, okay, it probably has to do something with this Rx. I could call it something else, but that wouldn't be nice. Here, these are terminal code: input to function block and functions, and output from function block and function. For functions, of course, it's the function itself that's output. That is the output, it's not. But here are some codes that you can use. I'm going to just, let's say, if you use our active and passive for our state machine up here, XGH, external position high, it is in its active state. That's a feedback from our process into your system. XGL is the opposite, low, because this system uses low and high for active and passive. Whatever. Another example, there's something for output. We could use another example. These in automatic mode. Automatic mode means that the operator, this is a processor running all by itself, and some part of the program wants to open this valve for the transit to high and low. We'd use the XH input. So it's a command, set external high, switch to high, and then you would expect to get this back. And these are inputs and output to your function block, and so on. It's not in your input image or output image. These are the input and outputs for your function block. Let's see, output, here's one, fault output, they are Y, in general Y, the binary status, that states information. Whenever you make a program, you have to at least tell if it executed okay. So if fault is false, it executes okay. If YF turns true, something went wrong in your program. You could output some information too if you want to, in addition. Say, okay, what happened? No, if it was this from active to passive or low to high. No, it didn't transit from low to high. The YF is true, and I make an output that I call something YFI for information, whatever. It's not according to this system, where I write a number or a text that says, okay, open fault or high fault or whatever it does. And this norm too, with the terminal codes, input and outputs, has also some concepts that it uses. High and low I've talked about. We have cause and effect type of objects. Effect objects can, or output objects, it's typically a valve controller. It manipulates an actuator, get a feedback. And then we have cause function, just an input. Could be a temperature input or something like that. It shows something on the HMI. but that doesn't do anything in the process. Here we got some concept too: suppress, disabled. Suppressed says what it does. Yes. What's important is disabled, because this has to do with these effect objects. Disable is not allowed to do. We can decide in the code. So this is interlocking. It can't go to this state as a part of interlocking. But if it is in this state, let's say if it's this element that's in high state, it is in high state. I disabled high state. Well, it will stay there. But safeguarding on the opposite is, that's real interlock. It is in the high state. I say go to the low state. It switches to the low state automatically. And there are two types, force and lock. And these are concepts used in this norm. Here is something with blocking, because it has to do with override. Because if you have an operator in the system, he can always override this logic, because an operator is far more intelligent than your control. So it says, okay, I see it's safeguarded, but I want to override this and open it anyway, or put it to active state. Okay, and then there are control modes. That's defined in here. Manual mode, you control it as operator from a HMI screen. Automatic mode, your PLC does the control. You can go home and drink coffee. Outside mode, well, you are on your way home, but you're out in the process and you want to operate this valve with push button or something like that. So there are two outside modes. You can do control, or it's just displaying the state. Okay, this is active or passive, or something like that. There are two modes. They are defined. So this is just an extract. They have a naming convention for inputs and outputs. There's only naming convention that basically exists. PLC Open has something for some function blocks. But this one is for process control, or also for factory control. You could use it. This is an awfully quick run through how to program in PLC, because how to do the task that you want to program is difficult. So these are just guidelines. Don't write two statements on a single line. How to organize your program, arrange your data, validate your input, do whatever you want to do. Write to your outputs. So these are function blocks. When you are done with your processing, if you want to display something on an HMI system, do it when you're done. Don't do it in the middle of the program, and so on. And what it is, there is a system for timing that you can use in the Semantic PLC, also in other PLCs. If they have this, there are other PLCs where you can get this Unix time or long time. Then you can do the timing. You have two types, one with millisecond, where you could wait, for instance, for up to 24 days. And then we have one with a number of nanoseconds since 1990, where you can wait for 500 years, which is sufficient. Yes. And then there was something about this with say real number exceptions and so on, that you have to validate the result. And then at the end we looked at some Hungarian, how to name your variables, so that you can look at the name in your program and say, okay, this is an integer, it's temporal, it's a temporal value, so I have to initialize it. It's static, okay, I can just pick it up in the next loop, because it's going to save to remember my data, and you don't need to hover your mouse over and look at the tooltip. Okay, static, integer, okay. So use use long names, camel case, capital first letter, lowercase letter, capital first letter, next word, and so on. No underscore. What else did we look at? That was the naming convention. Yes, it's really quick. Of course, programming in TI Portal or the PLC takes practice. That's just the way it is.